Hey everyone, I hope you are all doing great. Welcome back to another video in our Generative AI in Testing series. In our previous video, we explored the fundamental concepts of artificial intelligence, machine learning, deep learning, and generative AI. To quickly recap, generative AI takes an input known as a prompt. The user or an application that communicates with the generative AI provides an input in the form of a prompt. It can be a plain text or can be a video or can be an audio. Then the large language model processes this prompt and generates an output based on its training data and the context that is being provided. However, the results generated by AI aren't random. Various parameters influence the way these models respond, shaping the quality, creativity, and accuracy of their results. In this session, we will take a deep dive into the building blocks of LLM and explore the key parameters that shape their output. I will also demonstrate how these parameters influence the response in practice using OpenAI. LLMs, the brain behind the generative AI. Let's take a moment to understand the engine driving the generative AI, which is called as large language model or LLM. LLM is a foundational AI model trained on massive amount of text including books, articles, websites and more. Unlike traditional rule-based system, LLM do not follow the predefined logic. Instead, they learn from the pattern, structures and relationship within the data. How does LLM work? LLM takes a text as an input, that is user provided prompt. It processes the input using its training knowledge. It processes the input and it predicts and generates a response based on the probabilities, the grammars and the learned patterns. This image shows the fundamental building blocks of large language model. The user input or a prompt undergoes lot of pre-processing before it fed into large language model. The large language model further processes the pre-processed prompt based on the pre-training, and also sometimes it uses the fine-tuning to give the response to the user in an user understandable format. Let us go and understand each of these building blocks in detail. The first step of pre-processing is tokenization, which is breaking the input into smaller units. LLM don't process the entire word directly. Instead, the input is broken down into smaller tokens, which could be words, subwords, characters. For example, the prompt artificial intelligence is amazing could be broken down as the subwords like artificial intelligence, is, amaze, ing, and a character. LLMs only work with numbers, so each of these subwords or tokens are then mapped into a unique numerical ID from a predefined vocabulary. For example, here artificial could be mapped into a numerical ID of 500, intelligence could be mapped into a numerical ID of 3015 and so on. These numbers act as a reference in the model's vocabulary. Next step is embeddings. A token ID, for example here 5000, it alone does not capture its meaning. So it is further transformed into a vector representation called as an embedding. What is a vector? Vector is just an array of number that represents words meaning in a multi-dimensional space. For example, the conversion of this numerical ID 5000 into vector looks as an array of numbers. The words with similar meaning have a similar vectors. The words with a similar meaning have a vector which is very close to each other. For example, in a vector space, animal like dog and puppies are positioned close together compared to the vehicles like cars and vans. This table shows the sample vector representation for the sentence artificial intelligence is amazing. Next step is contextual embedding. Large language model uses the contextual embedding to dynamically adjust the word's representation based on their surrounding text. This allows them to better capture the synthetic relationships. For example, consider the word bank in these two sentences. She went to the bank to withdraw the money. He sat by the river bank and enjoyed the sunset. LLMs with contextual embedding generate different vector for bank in each of these sentences, recognizing that the first one refers to the financial aspect and the second one refers to the river edge. The contextual understanding enable the LLMs to disambiguate the word meaning based on their context, improve the accuracy in the tasks like translation, summarization, and sentiment analysis, generate more human-like and context-aware responses. The response from the LLM will be different for these two sentences. Once the pre-processing is done, it's a time for an LLM to generate a response for a given prompt. Now the LLM begins searching for a response based on a vast amount of data it has been pre-trained on. It generates a response using a combination of pattern recognition, that is identifying the language structures and relationship learned from training the data. Second one is probability distribution, predicting the most likely next word based on the contextual probabilities. The LLM does not retrieve the pre-written answers. Instead, it predicts the response one word at a time, based on the tokenization. Each prediction is based on the input question and the word it has already generated. For example, for the prompt, the capital of France is, the LLM assigns the probability to the possible next words. That is, for Paris, it is 85%, it is most likely to be the response, London 5%, and Berlin is 3%. The model chooses the Paris because it has got highest probability. The process repeats until the complete and meaningful response is formed. Once the response is predicted, the next step is to fine-tune the response. This process is called as refining the response for coherence. After generating the response using the prediction, LLM ensures the fluency and coherence by adjusting the grammar and sentence structure, ensuring the readability, the contextual consistency, avoiding the contradictions, and logical flow, maintaining the clarity. Some advanced LLMs refine the responses iteratively, meaning they adjust previously generated words if needed. They re-evaluate the entire response in a longer or an iterative conversations. This is in a nutshell how the LLM processes the given prompt, derives the response, and present it in a user-readable format. There are several important parameters that control how an LLM generates the response. The most critical ones are temperature, that controls the creativity, top K sampling, controlling the word choices, top P, dynamic word selection, token length, limiting the response size, frequency and presence penalty, avoiding the repetition of the responses. We will explore the behavior of each of these parameters in practice using the OpenAI platform. But before we dive in, it is important to understand the two main ways OpenAI provides access to its models. The first one is a ChatGPT interface. You can see here. It's a simple user-friendly chat interface where you can enter a prompt and receive a response. However, you have no direct control over the parameters that acts on the models. For example, let us ask a question: what is the capital of India? Capital of India is New Delhi. So For a given prompt, you can expect a response, but you don't have any control on this response. That is because you have no ways to control the parameters that controls the LLM response. The second interface is OpenAI platform. It's a more flexible option that allows the developers to interact with the LLMs through the APIs. They expose a lot of APIs to work with the LLMs. Here the user can fine-tune the responses by adjusting various parameters such as temperature, top K sampling to control the model's behavior. To access the OpenAI platform, you need to have an account, an API key, and configured with a payment setup. I have created a series of screenshots to guide you through the process of creating an account, configuring the API, and setting up the payment easily for the OpenAI platform. In Google, search for OpenAI platform and select the first one in the search result. Clicking on the link will bring you into this particular page, and you will have an option to either log in or sign up. If you already have an account, you can log in, or a first time users, you will have to sign up. Click on the sign up button. You will be asked to create an account using an email address or an existing Google account. So I have used continue with Google. Then it will ask you to enter your username and password, and then after entering you can just use continue. Then OpenAI platform will ask you for some details like your organization name, whether it is a personal account or a business account. In my case, I have chosen personal account, and it also asks you to describe yourself. I have told here I have entered I am somewhat technical, and then you can basically click on create organization. Then it brings out a screen where it asks you to create an API key. So you'll have to give an API key name and your project name. In my case, I have given it as test troop key and test troop project, and click on generate an API key. Once the API key is generated, it's your responsibility to keep that key safe. You just copy this key and keep it somewhere safely. So you will be prompted with the screen like this, where you can copy the key that is being created for you. Then click continue to continue the operation. After that, it will ask to set up an payment method. So in this case, you can give what kind of the payment method that you want to select, like 5 credits, $5 credits, or a $10 credits, or a $20 credits. So you can also skip the credits, like I will buy the credits later, or you can complete the purchase detail. So one thing has to be remembered, that in order to work with the platform OpenAI, you need to have your payment setup. Otherwise, it will not allow you to work with the platform. For the payment setups, it will ask you to enter your card details, name on the card, and the billing address, and click on, after you fill these details, click on continue to proceed further. So once the setup is done, you are now ready to use the OpenAI platform. In my case, my setup is ready. I have already logged in, and if you see here, I can go to my profile. So this is my username. If you click on my username, you can see these details. Click on your profile to go to your profile, and under this you can see all my details, like my name, my email address, I have not given my phone number, my API keys, okay, and also my billing details. Okay, now my profile, the account is ready to use. So in order to play with the parameters that I explained earlier, you need to go to the playground. Click on the playground button here. This will take you into an interface where it provides you to enter a prompt, as well as control the response using the parameters that we discussed. Under this section, you can see the list of models that you can work with. So this will show a list of models that are available from the OpenAI platform. Currently we are using GPT 4.4. Similarly, there are a lot of other models that are available like Turbo, 3.5 and etc. So for a time being, I will use this model. And also it is asking us what kind of response format that is you are expecting. You can have a text or a JSON object or a JSON schema. For a time being, I will be using it as text. Then you will have a lot of the parameter, the model configuration, like the temperatures, the tokens, and the top P, frequency penalty, and the presence penalty. Okay. Now let us try to understand these parameters one by one. The first one is about temperature. Temperature is a parameter that basically controls the creativity of the output response that the model provides. Okay, lower the value, it will become less creative and the answers will be predictive. And if you increase the temperature value like high, then it will give you, it will become more and more creative, and there will be a varieties of answer that you can get it. So the as I told, higher the value, there will be a lot of randomness, and generally the higher values you can use it for the storytelling, brainstorming, and for the creative writing. Let us try to play the creativity with the creativity of the model by controlling the temperature parameter. Let's ask the model to complete the sentence. Once upon a time, there was a dragon who ... So with 1.2, and let us increase the token of the response, that is number of the words that the output response contains, which is basically controlled by the maximum tokens. Let us give it as I want to get a response within the 100 words. Okay, so let us run this and see what is outcome with the temperature value as 1.12. So it gave us this particular response, and let's increase the temperature value, make it as around 100 and or 1 point, around 1.5, and try to ask the same task, like complete the sentence. Let's see the response here. Yeah, the response is different. Here it started with once upon a time there was a dragon who lived the highest peak of the Misty Mountains. But here it became more creative, telling that once upon a time there was a dragon who lived to collect the stories. Unlike the other dragons who hoard gold and jewels, this is started with a different and more creative story. Okay, this is how the creativity of the model can be controlled using the temperature value. See, the lower the temperature, then you will get a factual answers. Higher the temperature, you will get into creative, you will get a creative answers. Okay, mostly for definition, for coding, for mathematics, it is better to use the lower temperatures. But if you are trying to write a storytelling, brainstorming, or some creative document, then it is good to increase the temperature values. Top P is all about dynamic word selection. It is a way the model chooses the next word in a sentence. The model picks up the smallest set of words that together make up certain percentage of the total probability. While generating the response with top P, the model looks all possible next words. Then it sorts them by how likely they are. Then it picks the words from the top until their total probability reaches the value P, that is likely 90%. From this set of words, the model picks up the next word. The top P helps the model to make a decision by narrowing down the options based on their combined likelihood, making the output more natural and less random than just picking up all the words. Value of P equal to 0.9, the model picks the top 90% of probable words, allowing for a diverse but relevant responses. With the value lower, that is 0.3, the model sticks to a safer, more predictable choices. Top P provides a balance between diversity and coherence, making the responses more natural and context aware. Let us try to understand top P with the help of an example. Let us ask the LLM to describe a forest in one word. Let us reduce the value of P to 0.2 and see what is the response of LLM with P equal to 0.2. That means it is going to it is going to describe the forest in less probable words, right? So let us try to execute it. It gives a response like it is a lush, vibrant ecosystem, teeming, diverse, etc., etc. So it brings out the word that is close to the word forest, but they are not they are not that close, right? The words that is coming, they are not that close. It's not the probable words that is used to describe the forest. Let us now keep the value P as high as possible, like 0.9, and let us see the response and what kind of words it use to describe the forest, whether it is very close to the forest or not. If you see here, it says the forest is a vast. See, it uses the word like vast, it uses the word like towering of the trees, living canopy, rich tapestry of flora and fauna. So it brings a list of words that are very close in describing the forest. Okay, keeping the value top P as high as possible brings the words which are very close to the word that you asked to describe. Here the word forest, right? So it brings the words like the vast, trees, towering trees, living canopy, the flora, fauna, etc. that are generally used to describe the forest, right? But here it tried to bring out the words which are very less likely to be used to describe the forest. That is how the top P basically controls the response of your LLM. Max tokens, as the name indicates, it limits the size of the response. So let us keep it as 100 and let us ask a question. Describe a forest. It describes the forest within 100 words. Okay, token is basically, so each of this is a token. For example, A is a token, forest is a token, ease is a token, A is a token. So it's basically a subword, right? It's a subword, and if you increase the token, for example, if I make it as 500, then it will try to describe the forest in 500 words. Sorry, I have to give the request here. I did not give any request, that is why it thrown an error. Let us try to do this. See, if you see here, it is trying to describe a forest in 500 words. That is how the length of the response is basically controlled using the maximum tokens. The next two parameters, the frequency penalty and presence penalty, basically reduces the repetition. The frequency penalty discourages repetitive words based on their occurrence in the response, whereas present penalty discourages the words that were already used in the prompt, encouraging the model to introduce new ideas. So it basically discourages the repetition of the words. Okay, so the presence penalty will not repeat any word that is given in the prompt, whereas the frequency penalty discourages the repetitive words based on their occurrence in the response. So higher this value, the lower the repetition is. Okay, let us try to see, let us try to keep this as 63 and 50 and try to see the same. Let us clear this. Yeah, now if I give it as less, then there may be a chances there may be a repetitive of the words. So it is difficult to demonstrate that, but in general the meaning of the penalty is to control the repetition of the words in the responses. So these are the parameters like the type of the model, response text, the model configurations like temperature, maximum tokens, top P, the frequency penalty and presence penalty controls the outcome of the LLM responses. Just to recap on the parameters, lower the temperature, more precise the answer is. Higher the temperature, more creative the response is. Higher the value of top P, the model picks up most probable words. The lower the value of top P, the model picks up safer and more predictable choices. Frequency and presence penalties reduces the repetition and improves the variation. The higher the value, lower the repetition is. Lower the value, higher the repetition is. That brings us to the end of this session. In this video, we explored the underlying process by which an LLM generates a response to a given prompt and the list of parameters that controls the output. I hope you enjoyed learning with me. Please support my channel by subscribing and stay tuned for the next video. Thank you for watching.